Okay, so in this example here, we're going to be talking about how to find the discriminant and what that actually means. Now, this is pretty straightforward. It's not really difficult to understand, but the discriminant is simply just the portion of the quadratic formula, and in particular, the part that's underneath the square root. So for example, b squared minus 4ac, you can see that I have that written here, here, and here. So again, it comes from the quadratic formula, and it is the part underneath the square root. So if you were to write out the quadratic formula, you know it's negative b plus or minus square root of b squared minus 4ac all over 2a. So again, we're talking about this part right here, okay? And so what does it tell you? Well, it simply tells you how many zeros a quadratic is going to have. So for example, if you use the discriminant, and again, that is the part underneath the square root of the quadratic formula, when you plug in your coefficients, if that value is greater than 0, that tells you that the quadratic is going to have two real zeros, meaning it's crossing the x-axis at two different points. So for example, if you had a grid and you put on a quadratic, if it has two real zeros, it looks something like this, right? Where you have a 0 here and you have a 0 here, okay? Now, if you plug in your coefficients and the discriminant is equal to 0, that means there's one real 0. And essentially what that means is the quadratic is bouncing off the x-axis. So for example, if we draw in our coordinate grid, you would have something like this here, where the vertex of the quadratic is going to be bouncing off that x-axis, right? So again, right here. And then if you plug in your coefficients and it's less than 0, that means you're going to have two non-real zeros. So again, a picture of what that looks like if you draw it on your coordinate grid, that's going to never be crossing the x-axis. You're going to have something like this out in space, right? Where it's never crossing the x-axis. So you have two non-real zeros there, okay? So let's do a couple of examples modeling each scenario here. So here's our first example, and just like you would use the quadratic formula, you have to make sure that it's set equal to 0 before you use the discriminant, okay? So I have to take this positive 10 and I have to move it over. So my new equation is going to be negative 5x squared plus 3x, and then I have to do 5 minus 10, that will give me negative 5, right? And again, technically this is all equal to 0, right? But just labeling out our a, b, and c coefficients, right, we end up getting for a, negative 5, for b, we get 3, and for c, we get negative 5. And now plugging these values into the discriminant, we get the following. So I'll go ahead and write the discriminant right here, b squared minus 4ac, okay? So then plugging it in right below that, we get 3 squared, that's my b, right? Minus 4, my a is going to be negative 5. My c is a negative 5. So what ends up being our value here? Well, 3 squared is 9. Negative 4 times negative 5 is positive 20. And then 20 times a negative 5, you get negative 100. Okay? So we end up with negative 91 here. So if you go back to those three different scenarios, if the discriminant is greater than 0, that means there's two real zeros. If it's equal to 0, that means one real 0. And if it's less than 0, like we have here, we have negative 91, there's going to be two non-real zeros. So this particular quadratic has two non-real zeros. Okay? So we can go ahead and box that in. Meaning, again, it's not crossing the x-axis. So if you were to graph this quadratic, it would not be crossing the x-axis. All right, let's go ahead and try another example. Okay, so here's our next example. And again, we have to move this 4 over to the left-hand side to make it equal to 0. So when we do that, we get negative 8x squared minus 16x. And then I have to do negative 4 minus 4 because, again, I have to subtract this 4 over. So I end up with negative 8. And again, all equal to 0. Listing out my coefficients, I have a is equal to negative 8. B is equal to negative 16. And then C will be equal to negative 8, okay? So plugging it into the discriminant, we get the following. We get b squared minus 4ac. So that leaves me with negative 16 and then squared minus 4. My a is negative 8. My c is a negative 8, okay? So negative 16 squared will give you positive 256. okay? -4 times -8 is positive 32. And then positive 32 times a -8 will actually give you negative 256. So 256 minus 256 is 0. Go back to your 3 different scenarios. If the discriminant is equal to 0, that means there's one real 0. So we have one real 0 here. So what does that mean if you were to graph it? Well, that means that it's going to be bouncing off the x-axis, meaning the vertex of this quadratic will be bouncing off that x-axis, okay? All right, let's try one more example. So here's our next example. Same thing, we have to take this positive 8 right here and move it over. So that's what we're gonna do. We get negative 8x squared plus 6x. 28 minus 8, I get plus 20. And again, all equal to 0. Let's list out the coefficients, A, B, and C. A is -8, B is 6, and C is 20. Writing out the discriminant, we get B squared minus 4AC, and then right below we can start plugging it in. So my B is 6. So 6 squared minus 4, my A is a -8, and my C is positive 20. So 6 squared will give you 36. -4 times -8 will give you positive 32. And then 32 times 20 will give you 640. So I get plus 640 here. And then I know that 36 plus 640 will give me 676. So again, go back to your 3 different scenarios. In this case here, the discriminant is greater than 0 because I have 676 here, meaning I'm going to have 2 real zeros. So 2 real zeros. So what does that mean graphically? Well, if you were to graph this quadratic, it's going to be crossing the x-axis at 2 different points, okay? So that is the discriminant, and that is how you use it. It essentially comes from the quadratic formula, and that's all there really is to it. It essentially tells you how many and what type of zeros you're gonna have when dealing with a quadratic. So that's pretty much it. Now, if you found the video helpful or if you gained something from the video, please go ahead and give it a thumbs up. That would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.